Are we alone in the universe? We're asking this question because we have our sights set on over 5,000 exoplanets that we've found so far, but we can't figure out which ones could support life. With all the talk about second Earths, ocean worlds, and exciting discoveries by the James Webb Space Telescope, how do we tell where life could exist? And do we even want to? Let's dig into the science together. Welcome back, everyone. I'm here to help you understand how we find and study exoplanets and what we're looking for when we ask the question, are we alone? It's me. Now let's get into this whole habitability thing. You may have heard the term habitable zone before. That's a fancy way of describing the region around a star where conditions could allow a rocky planet to have liquid water on the surface. This is based on our experience with Earth, which has an ideal distance from the Sun and an atmosphere and magnetic field that keep it at just the right temperature. So we assume that other rocky planets need these three things to support life as we know it. But there's more to the story because a planet's environment is more than just a matter of distance from its star. A planet's atmosphere plays a huge role in determining its climate. If a planet doesn't have much of an atmosphere, any water on the surface will quickly boil away into space. But if it has too thick of an atmosphere, well, that can trap too much heat and turn a planet into a runaway greenhouse like Venus. On Earth, our atmosphere protects us from dangerous space radiation and helps regulate our climate. Plus, it even recycles elements like nitrogen and oxygen, which are crucial for life as we know it. And that's why many scientists think that other potentially habitable worlds would also need some sort of atmosphere to support life. Liquid water is considered an important ingredient for life as we know it. It's a fantastic solvent, meaning that it dissolves more substances than any other liquid and can transport chemicals and nutrients dissolved in it. Just think about how water dissolves salt and sugar. You can't see those molecules individually, but you can see what they make in a glass of lemonade. Water's polarity allows it to dissolve stuff that's polar itself, which makes it possible for water to carry dissolved substances across cell membranes and play a key role in chemical reactions. But having water isn't enough. It needs to be in liquid form. And for that, we need our third key ingredient, a magnetic field. Earth's magnetic field acts like an invisible force field deflecting harmful solar wind, keeping our atmosphere from being blown away into space. Without this protection, our planet wouldn't have an atmosphere and it would freeze. Scientists think that other rocky planets would need something similar to protect their atmospheres. So, if you want to be on the lookout for life elsewhere in the universe, you need to consider all of these three factors. And remember, while we're going to focus on the idea of life as we know it in this video, the universe has a funny way of surprising us. It might be that there's plenty of life out there, but it just doesn't look like anything we know. Consider that life on Earth comes in a wide variety of forms, from creatures that thrive in boiling hot springs to others that live deep inside rocks or ice, or even organisms that don't use DNA as their primary genetic material. Who's to say that life elsewhere couldn't be totally different from life here? Okay, now that we have a basic understanding of what it takes to support life as we know it, let's talk about two potentially habitable planets. The first is Kepler 438b. It's slightly larger than Earth and orbits a red dwarf, a small, cool star. Red dwarfs are very common, making up roughly 3/4 of the stars in the Milky Way. This means that there are likely lots of potentially habitable worlds orbiting red dwarfs. However, they come with their own unique challenges. Red dwarfs tend to be very active, regularly flaring up and blasting powerful bursts of radiation into space. This poses a danger to any nearby planets which could lose their atmospheres and get stripped of their water over time. Another problem is that planets orbiting red dwarfs often have unstable orbits. They might be tidally locked to their star, meaning that one side always faces the star and the other side is in permanent darkness. Or they might orbit very close to their star, resulting in scorching temperatures on one side of the planet and freezing temperatures on the other. In spite of these challenges, Kepler 438b has been touted as one of the most promising candidates for life in the universe. Located about 470 light-years from Earth, it's about 12% smaller than Earth and receives about 30% more sunlight. It lies within the habitable zone of its star, suggesting that it could have liquid water on the surface. However, recent research suggests that the intense radiation from its star may have stripped away its atmosphere over time. While it may not be a welcoming world today, it could have been a suitable environment for life billions of years ago. Another potentially habitable planet is TOI 700d. This rocky super-Earth is about 40% larger than Earth and orbits a star located 100 light-years away. It receives about half as much sunlight as Earth, putting it right on the edge of the habitable zone. What makes this planet interesting is that it was discovered by NASA's Transiting Exoplanet Survey Satellite, or TESS. TESS is designed to find small planets orbiting nearby bright stars using the transit method. This method involves looking for the dimming of a star's light as a planet passes between us and the star. When TESS detected the dimming of TOI 700, it wasn't sure if it was caused by a planet or something else like a star that was slightly larger than Jupiter. Follow-up observations with the Spitzer Space Telescope confirmed that it was indeed a rocky planet. However, further analysis revealed that it might be tidally locked with one side permanently facing its star and the other in darkness. While this would make for some extreme temperatures, researchers think that if there was enough atmosphere, it could potentially transport heat from the day side of the planet to the night side, creating a more hospitable environment. Additionally, the mass and size of TOI 700d suggests that it could have a significant amount of water. It's important to note that both Kepler 438b and TOI 700d are just two of the thousands of exoplanets that have been discovered. There are likely many more potentially habitable worlds out there waiting to be found. So there are quite a few weird contenders for potentially habitable planets. Ocean worlds, for example, are icy planets or moons that could have a liquid ocean beneath their frozen crusts. Saturn's moon, Enceladus, and Jupiter's moon Europa are examples of ocean worlds in our own solar system. Tidal worlds are planets that are tightly locked to their star, which could lead to extreme temperatures on one side of the planet, but also potentially create a habitable zone along the terminator, the line between day and night. Even planets with a runaway greenhouse like Venus could potentially be habitable if life finds a way to thrive in extreme environments. While it's fun to speculate about these possibilities, it's important to remember that we haven't found any definitive evidence of life elsewhere in the universe yet. But the search is on. NASA's launched the Mars rover named Perseverance to search for signs of ancient life on the red planet. And the James Webb Space Telescope is searching for biosignatures in the atmospheres of potentially habitable planets. Biosignatures are basically any sign of life, like the presence of oxygen or methane in a planet's atmosphere. These telescopes are working together to answer the question, is there life out there? To understand what's happening, let's take a closer look at JWST. This telescope is designed to observe infrared light, which allows it to see through clouds of dust and gas. By analyzing the light that passes through these clouds, Webb can identify the chemical composition of the objects in space. For example, when light from a distant star passes through a planet's atmosphere, some of the light gets absorbed by gases in the atmosphere depending on the type of gas. The amount of light absorbed can tell us how much of that element is present. We can also tell how much water vapor is in a planet's atmosphere by observing the amount of starlight that gets blocked by the gas. By measuring the amount of starlight blocked, we can tell how much water vapor is in a planet's atmosphere. This gives us clues about the planet's climate and its potential to support life. But Webb can do more than just analyze the atmospheres of planets. It can also observe the surfaces of planets and moons. By studying the reflected light from these objects, Webb can identify the types of rocks and minerals present. This can tell us whether the object is made of ice, rock, or something else. It can also reveal the presence of water, ice, or other organic molecules, which are building blocks of life. And what is NASA doing right now? Well, One of the missions aims to discover and characterize potentially habitable worlds beyond our solar system. Its primary goals include identifying planets that could support life, characterizing their atmospheres, and searching for biosignatures. To do this, the rover explores areas that were once habitable, looking for signs of past life. Meanwhile, Hubble observes the atmospheres of exoplanets to identify their chemical composition and search for biosignatures. Together, these missions are taking us one step closer to answering the question, are we alone in the universe? The greatest hunt in human history is happening right now. It's the hunt for life elsewhere in the universe. Join us as we explore the latest discoveries and answer the age-old question, are we alone? Click below to subscribe to the channel and never miss an update. Thanks for watching. See you next time.